Today, we're going to explore a fascinating mathematical concept, the factorial of 1/2. While we're familiar with factorials of whole numbers, like 5 factorial equals 5 times 4 times 3 times 2 times 1, what does it mean to take the factorial of 1/2? Let's find out. The key to understanding this lies in the gamma function, denoted as capital Gamma of x. The gamma function is defined by the integral, gamma of x, equals the integral from 0 to infinity of t, to the power of x minus 1 times e to the power of negative t, dt. This function extends the factorial concept to complex numbers. For positive integers n, it satisfies. Gamma of n equals n minus 1 factorial. Let's prove this relationship between the gamma function and factorial. For a positive integer n, we can write gamma of n as gamma of n equals the integral from 0 to infinity of t, to the power of n minus 1 times e to the power of negative t, dt, using integration by parts with u equals t to the power of n minus 1, dv equals e to the power of negative t, dt, we get d equals n minus 1 times t to the power of n minus 2, dt, v equals negative e to the power of negative t. Applying integration by parts, gamma of n equals negative t to the power of n minus 1 times e to the power of negative t, evaluated from 0 to infinity, plus n minus 1 times the integral from 0 to infinity of t, to the power of n minus 2 times e to the power of negative t, dt. The first term evaluates to 0 at both limits, so gamma of n equals n minus 1 times the integral from 0 to infinity of t, to the power of n minus 2 times e to the power of negative t, dt, which equals n minus 1 times gamma of n minus 1. This gives us the recurrence relation, gamma of n equals n minus 1 times gamma of n minus 1. Starting with gamma of 1 equals 1, we can show gamma of 2 equals 1 times gamma of 1 equals 1, gamma of 3 equals 2 times gamma of 2 equals 2 times 1, gamma of 4 equals 3 times gamma of 3 equals 3 times 2 times 1. In general, gamma of n equals n minus 1 factorial. This proves that for any positive integer n, the gamma function evaluated at n equals the factorial of n minus 1. To find the value of 1/2 factorial, we need to evaluate gamma of 3/2, since 1/2 factorial equals gamma of 3/2. The gamma function has a special property. For half integer values, gamma of 1/2 equals the square root of pi. Let's prove this remarkable result, starting with the definition of the gamma function. Gamma of 1/2 equals the integral from 0 to infinity of t, to the power of negative 1/2 times e to the power of negative t, dt. Making the substitution u equals the square root of t, we get t equals u squared, dt equals 2u. This transforms our integral to gamma of 1/2 equals the integral from 0 to infinity of 1 over u times e to the power of negative u squared times 2u, which equals 2 times the integral from 0 to infinity of e to the power of negative u squared d. This is the famous Gaussian integral, which equals the square root of pi. Therefore, gamma of 1/2 equals the square root of pi. This elegant result connects the gamma function to one of the most fundamental constants in mathematics. And we can use the recurrence relation, gamma of x plus 1 equals x times gamma of x. Therefore, gamma of 3/2 equals 1/2, times gamma of 1/2 equals 1/2 times the square root of pi. So, 1/2 factorial equals 1/2 times the square root of pi, which is approximately 0.8862. So good.